Hello everybody, I am Syed on Maths Online. In the previous video we are seeing some examples based on Lagrange linear PDE. We'll try to continue with few more problems on Lagrange linear PDE. So the question is, solve y minus z times of p plus z minus x times of q is equals to x minus of y. Now this is of the form pp plus qq is equals to r. So therefore the value of p over here, capital P, is y minus of z, the value of capital Q is z minus of x, and the value of capital R is nothing but x minus of y. Now the auxiliary equation will be dx by p is equals to, it is dy by q is equals to dz by r. So plug in the values of p, q and r. We'll get p value is y minus of z, q value is z minus of x, r value is x minus of y. So here if I try to group the first two terms and the last two terms, I cannot express this in the form of variable separable. Therefore what has to be done is you have to use another method, maybe a multiplier method. In case suppose if I try to add these three expressions or subtract these three expressions or multiply by some multiplier, so that we are able to separate the variables or we are able to integrate it. If you try to observe here, this expression in the denominator, it is y minus of z, z minus of x, x minus of y. It is in the symmetric form. Suppose if I add them, the denominator will be equals to 0. So therefore I can say that using the multiplier, one for the first case, so just multiply by 1 in the numerator and in the denominator, so multiply. So here also second term 1 and the third term 1, so multiply by 1 over here, will get dx, just add it, plus 1 times of dy, then 1 times of dz, whole divided by, since you are multiplying by 1 you get the same expression, it is y minus of z, then plus z minus of x, plus the next value is x minus of y. Now if you try to rewrite, it is dx plus dy plus dz, whole divided by. If you try to observe over here, this is plus y minus of y minus x plus x minus z plus z, everything will cancel out, will get equals to 0. So which means that the value of dx plus dy plus dz is equals to 0. So dx plus dy plus dz is equals to 0. Now you can integrate it. Integral of dx is x, integral of dy is y, integral of dz is z, is equals to c1. That's the first solution you got. For the second solution, you need to check for another multipliers. So because these terms y, z, zx, xy, they are symmetric in nature, therefore you can use multipliers as x, y and z. So let us try to take the multipliers as x, y and z. So using the multipliers, x, y and z. So here we will try to take the multiplier as x, that is x times of dx, plus in the second case the multiplier will be y, so y times of dy. In the third case we are taking it as z, so z times of dz. Those are the multipliers that we have. So whole divided by, because you have multiplied the first term by x, the denominator of that expression has to multiply it by x, so you will be getting x times of y minus, it is x times of z. The next term is multiplied by y, so it is y times of z minus y times of x or xy. Next term is multiplied by z, so z times of x minus, it is z times of y. So if you try to observe over here, this is plus xy and it is minus yx or xy, both are the same. So positive and negative value get cancelled. Here you have plus yz and here it is minus zy or minus yz, it will cancel out. Here zx plus zx, here minus of zx, that will cancel out. So you will be getting the expression to be equals to x times of dx plus y times of dy plus z times of dz whole divided by 0. So therefore the value of x dx plus y dy plus z dz, its value is equals to 0. Now you can integrate it. So integral of x into dx plus integral of y into dy plus integral of z into dz is equals to some constant of integration c2. So let us try to integrate this one. So integral of x comes out to be x square by 2. Integral of y will be y square by 2. Integral of z will be z square by 2 is equals to c2. Or if you take the LCM as 2, you will be getting it as x square plus y square plus z square is equals to c2. Cross multiply 2, you will be getting x square plus y square plus z square is equals to this 2 times of c2. So therefore you have got two solutions over here. So let us write down the final solution is 5 of, what is the first solution I have got? X plus y plus z. And what is the second solution? The second solution, you got it as x square plus y square plus z square is equals to 0. Let's take the next question. Solve y square plus z square times of p plus x into y q minus z is equals to 0. But it is not in the Lagrange linear PDE form, so we'll try to simplify this one. Y square plus z square times of p plus multiply this x inside, it becomes xy cube. Again it's plus into minus minus x into z or zx is equals to 0. Or further you can simplify, it is y square plus z square times of p plus xy times of q is equals to, you take this zx on the other side, it becomes plus zx. Now this is in the form of pp plus qq is equals to r, where the value of p is nothing but y square plus z square. Your value of q is nothing but xy and your value of r is nothing but zx. Now if you write down the auxiliary equation, the auxiliary equation will be dx by p is equals to, it is dy by q is equals to, it is dz by r. So you have dx by the value of p is nothing but y square plus z square, it is dy by the value of q is xy, then it is dz by the value of r is zx. Now if you try to see again grouping, we don't get the solution. Now suppose if I group the last two expressions here, let us try to see whether we get in the variable subrule form or not. Suppose if we cancel out this x and x, you get dy by y, dz by z, which will be in the variable subrule form. So you can consider these two equalities. So we'll try to consider, it is dy by xy is equals to, it is dz by zx. So you can see this x and x will cancel out. You will be getting the value as dy by y is equals to, it is dz by z. So let us try to integrate this one. So if you try to integrate, we get the expression to be equals to, is integral of dy by y is equals to integral of dz by z. Because we know that its integral will be log, therefore you need to add the constant of integration as log of c1. So you get log of y is equals to, there is log of z plus log of c1. So if you take log z on the left hand side, it becomes log of y minus log of z is equals to, it is log of c1, or it is log y by z is equals to, it is log of c1. So we try to eliminate log, you'll be getting y by z is equals to c1. That's the first solution you got. Now we need to get one more solution. So go back to the auxiliary equation. There is only one possibility we had. Now the other way that you can take is you can use the multipliers over here. So will the multipliers x, y and z work here? Let us try to see. Suppose if we try to use the multipliers over here. Use multipliers x, y and z. So will this x, y and z work here? Let us try to see. Here is y square is there. Suppose if you multiply by x in this case, because I'm multiplying by x, xy square, by y in this case, so xy square, both are positive. So one should be positive, one should be negative. So this value should be negative over here if you want to cancel out it. So you can take the multiplier for y to be minus y. So x will be positive, y will be negative. Here also, because plus z square is there, here you will be multiplying by z and here z. So z square x. So this should be negative because here you have positive. To cancel out, it should be negative. So minus of z. So you can use the multiplier as x minus y and minus z. So if you use it, we will be getting x dx divided by x times of y square plus z square. So you can continue. It is minus y times of dy minus z times of dz. Here the denominator will be, you have to multiply by minus y. So minus x into, you are multiplying by y, it is y square, minus z. So you are multiplying by z, it is z square times of x. So if you further simplify this expression, we will be getting x dx minus y dy minus z dz whole divided by, multiply x inside, we will be getting xy square plus, it is xz square. Here minus xy square minus, if you want to rewrite it, you can write it as xz square. So you can see that plus xy square minus xy square will cancel out, plus xz square minus xz square will cancel out. You will be getting the equation to be equals to x dx minus y dy minus of z dz whole divided by 0. So therefore you get the expression to be x dx minus y dy minus z dz. Its value is nothing but 0. So now you can integrate, because they are in the variable separal form. Integral of x dx minus integral of y dy minus integral of z dz. You need to add the constant of integration as c2. So integral of x will be x square by 2. Integral of y will be y square by 2. Integral of z will be z square by 2 is equals to c2. If we take the LCM as 2, we will be getting x square minus y square minus of z square is equals to c2. Cross multiply 2, we will be getting x square minus of y square minus z square is equals to 2 times of c2. That is equation number 2. So both the solutions have been obtained. So the final solution will be 5 of the first solution. First solution is nothing but your equation number 1, which is nothing but y by z. It is y by z. The next solution here, it is x square minus of y square minus of z square is equals to 0. So that gives you the solution for the problem. Thank you.